In this video, what we're going to do is explore how to find the surface area and volume of both prisms and cylinders. But before we do that, we need to understand what makes something a prism and what makes something a cylinder. So shown here on the left is a rectangular prism. And the reason why it's a rectangular prism is because if you look at the top and the bottom, you'll see that both the top and the bottom are rectangles. And I'm actually just going to shade those in. So we have a rectangle down here on the bottom, and we have a rectangle that's congruent, meaning it's the same shape and the same size, opposite it on the top. And those two rectangles, or those two sides of the prism, or what we call faces, are really important because we're going to call those the base. And every prism has a base that is the same shape as its name. So for instance, a rectangular prism has a base that's a rectangle, a triangular prism has a base that's a triangle, and so on. The same is true for cylinders here. We have a cylinder, and in this case, the base of the cylinder is the circle. So we have a circle down here on the bottom, and we have a circle that is congruent on the top. So those two circles, which are congruent and opposite one another, are the base of the cylinder. And those bases are going to be really important to us when we find both the surface area and the volume of prisms and cylinders. To find the surface area and the volume, we first will need to understand what they are. And so the best way to do that is to take a look at the words. The surface area really is just what it implies. It's the area of all the surfaces. And in that way, it's kind of like perimeter in the sense that even though it has the word area in it, it's referring to the outside of the solid. All right, so surface area is about what's happening on the outside. Whereas volume is sort of more like area in the sense that it's about what's inside the solid. So it's the space inside the solid. Notice that area was the same thing. Area is about the space inside the two-dimensional shape, and this is the space inside the three-dimensional solid. So we're going to use these two things to kind of help us find both the surface area and the volume of the prism. I'm going to start with volume here because it's a little bit simpler to calculate. Now instead of giving a different formula for each different type of prism that we do, what we're going to do instead is we're going to use one formula to find the volume of every prism and in fact every cylinder. So we're going to start with this the same way. I mean, really what volume is it is the area of the base multiplied by the height. And you can think of it like this. If we were to put some cubes in the base here, we were to fill that up, that would give us the area. And then we would have to fill it up again, and again, and again, and again. So every layer we put on here adds to the volume. Well, those layers are represented by the height of the prism. So every volume sort of calculation can start with this one sort of master formula where volume is equal to base times height. Now what we're going to do is we're going to make it a little bit more specific for this shape. Volume equals, the big B is going to change to be the formula for the area of this particular base. So in this case it's a rectangle. And the formula for finding the area of a rectangle is base times height, and then we'll use multiplied by the height of the actual prism. So even though they're two h's, they mean different things. One's the height of the base, and one's the height of the entire prism. So now we'll substitute in some values. 4 times 3, and then times 6. So I can do this without a calculator. 4 times 3 is 12, and times 6 is 72. So 72, in this case, centimeters, and it's a three-dimensional, so it's cubed. Now, surface area is a little bit different. Surface area is the area of all of the surfaces. And once again, we could work out each individual sort of face by itself. That's 6 different calculations. Or we can kind of have a master formula. So a way to think of surface area is that we have a top and a bottom. So we have a base at the bottom and a base at the top. So we have two bases. And then we have these four sides that wrap around the outside of the shape, and these are called the lateral faces. And really, how we can find the area of all of the lateral faces together is to think about the fact that these have to wrap around the base, right? They have to wrap around the base here. And so that's the perimeter of the base, and then multiplied by the height of each of those faces. So the surface area of every prism can be found by finding the area of the base, multiplying that by 2, and then adding to that the lateral faces, which is the perimeter times the height. So now we'll write a slightly more specific formula where area of the base is base times height, and then the perimeter of the base times the height. So let's work that out. 2 times 4 times 3 plus the perimeter, and remember we can work out perimeter however we work it out. 4 plus 3 is 7 times 2 is 14 times the height, which is 6. So now we have 4 times 3 is 12 times 2 is 24 plus 14 times 6, that's a little bit harder, I think that's 84. And we add those two things together, 108 centimeters. And in this case, it's area, so it's squared. Now, in fact, we can use the exact same formulas for finding the volume and surface area of a cylinder. So I'll start with the volume again over here. And notice that because we have our two bases, and it's the same idea, right? We put in one layer, then we put in a second layer, and a third layer, and so on and so on. The volume of a cylinder is found the same way. Area of the base times the height of the cylinder. Well, in this case we have a circle, so the area of a circle is pi r squared times the height. And now we'll put in some values. 3.14 times, I think that was 4 squared times the height, which is 10. And so now I'll just break out my calculator, and I'll go 3.14 times 4 times 4, because it's squared, times 10 equals 502.4 centimeters cubed, because remember volume is three-dimensional. And now let's look at the surface area. We can do the same thing for the surface area. So surface area, right? We have the area of the two bases. So surface area equals the area of the two bases. And remember, this lateral face has to wrap around the base. So remember, that's the circumference of the circle. So the circumference, or the perimeter of the circle, times the height of that lateral face. So now we can substitute things in. Pi r squared. Perimeter is the same as circumference, so it's 2 pi r times h. We put in some values now, times 3.14 times 4 squared plus 2 pi 4 times 10. Oh, I'm getting a little bit crunchy here. I'm going to work this out with my calculator. 2 times 3.14 times 4 times 4 equals 100.48 plus 2 times 3.14 times 4 times 10, 251.2, and now I'll just add those together, which gives me 351.68 centimeters, and its area, so squared. And so that's how we can use these sort of two master formulas to help us find both the surface area and the volume of all prisms and all cylinders.